Okay, welcome to Thursday of week 7. And we have a new book at the bottom, Applications and Division of Polynomials. And I put inside this book the whiteboard we did last time. Let me just open that so you see what it is. Where we had those 9 different there they are. Okay, go away. There we go. So we had these 9 different ways to talk about using polynomial multiplication in real life. And we picked most of them, but didn't have time to do all of them. You could look at them more if you want. And so that is in the applications and division of polynomials book. But starting at the beginning, when you go there, as I mentioned, on Tuesday at the end, we have 2 different sets of goals for today. If you're only wanting the GED test, then these 3 things are the ones you care about. If you are thinking of doing some STEM classes or workplace trainings or other things, then these are ones you could care about also. So keep track of that yourself. Ask me if you have questions. The top ones I will go over with a little more detail than the bottom ones. I'm not going to worry about all of the special cases in the bottom ones. As always, we have our 2 textbooks and the sections there, the videos. Whoops, that should say Tuesday, typo. So Tuesday's video is here. Today's video will show up here after we're done. And I went through and found all the good, helpful YouTube ones. So if what we do here isn't enough, you can look at how other people explain things. The whiteboard, we have 2 whiteboards. The one I showed you from Tuesday, and then I'll open the link to the one that's just for today. No to-doodles, not much homework. And remember that not all of these are needed if you're just doing the GED prep, but it would be good to do other things. I haven't been remembering to do the group work quizzes or the discussion forums, and that's okay, because if we can always go back and fill them in later. If we look at our calendar overall, if I show you secret teacher stuff, revert to my normal. Then next week, we're going to be talking about square roots, and we're going to also do the scientific notation we skipped over earlier when we didn't have time, and the last week about solving quadratic equations with the quadratic formula, including with word problems. So if that's supposed to be 9 and 10, then we're a week ahead. This will be, for us, week 8 and 9. So we'll have lots of time for practice finals and going back over the discussions and group work that we're not always doing each week. I did some investigation about the final. It does have a time limit. It is 2 hours at the most. And there is the entire thing, calculators are allowed. So when you go to take your GED, on the real GED, there's a few problems at the beginning where you don't use a calculator. Things like reducing fractions that they want to make sure you can do without cheating with a calculator. But our final doesn't give you that practice. It is all calculators okay. Okay, that's sort of my announcement to start. Any questions, comments, things like that?
No.
Okay. Let's look at what we are doing today then. So again, we have 2 sets of goals based on if we are only caring about the stuff that's on the GED or doing a little bit more. And what we need to start out doing is thinking about how fractions work, because we're eventually going to have fractions that have polynomials in them. Maybe we will someday have a fraction like x plus 3 over x minus 4. And there are other fractions we're familiar with already. So by reviewing kind of what makes these things tick, then when we get them more complicated, then that will help us. Everyone ready to start with that?
Yeah.
Yes, okay. I hear at least Dusty's yeses. So I made a whole list of questions and we're going to go over this with both normal fractions and the fractions with equations in them, which are called rational expressions. Why do we call them a rational expression? It's because the word ratio is hidden in there. So a lot of fractions in real life come from measurement. How much flour do I put in my recipe? 3/4 of a cup. But a lot of fractions in real life are not a number between 0 and 1. Instead, they are a ratio, a comparison of things. Maybe you drive 3 miles every 5 minutes. And we'll treat that as if it's something that's a fraction. But it's not a fraction, it's a rate. Right? There's not some amount between 0 and 1 that's happening there. So these are things that are ratios. We're comparing two things. We're using a fraction bar instead of division. And that's why we're calling things. So again, kind of two interesting things going on. We have values between 0 and 1. And we have comparisons. And a rational expression is the same thing, except you have polynomials instead of normal things. Something like that. Actually, let me change some of my examples. Let's do I'm going to change this one to be something I can reduce. Okay. So when is a fraction reduced? Somebody tell me that in your words, and then I'll see if I want to try and explain it in other words or not. What makes a fraction reduced?
Um, when both sides of the fraction can be divided by the same number.
Yeah. Pardon me, I'm closing the door because the class next door is a bit noisy. Okay. Dusty said something great. I'm going to phrase it a little differently. He said both sides, and I don't want anyone to be confused with that. I'm going to say top and bottom rather than sides. And I could take 6/8 and say 6 is 2 times 3, and 8 is 2 times 4, and then the 2's cancel. Everyone okay with that so far?
Yeah.
Yep.
Why can I do that? How can I just get rid of twos? Why doesn't that change things? I can't just get rid of a two, can I? Oh, oops, I am forgetting. Let me put this in the chat so you can all join me and move around without having to get into Moodle. So Kayla puts in chat, by like terms. So let me justify canceling first with some numbers and then with some pictures, because sometimes people have brains that the numbers work well and sometimes the pictures. So I know how to multiply fractions. Think about going this way for a moment. To multiply fractions, I go across the top and across the bottom. So I could say 2 times 3 is 6. And I can say 2 times 4 is 8. But this fraction, the 2 over 2, that's just a different way to write 1. And if there's 1 times something, I don't have to write that 1. So that's our justification with numbers for getting rid of that 2 over 2, because it really is just a different way to write 1. So for people that like seeing it that way, questions on that explanation? Okay, so maybe you are a picture brain person. I'm going to have 6/8. So I'll shade them in. 1, 2, 3, 4, 5, 6. Then if I have this as like a tray of brownies, if I have some sort of magic frosting that glues the brownies together, I can get rid of this line in the middle. And now I've just changed 6/8 into 3/4 by gluing pieces together. That didn't really answer my question. What happened with this 2 over 2? Well, in the numerator, we went from 6 pieces that we cared about to 3 pieces. These were my pieces of brownie that I don't have to share. So each of those became half as many. And in the denominator, we went from 8 total pieces to only 4. Each piece got twice as big. So I get to scoop out half as many pieces, but each piece I scoop is twice as big. So overall, I get the same amount of brownie from this tray. So that's the picture way to say, why can I get rid of these twos? Because one is giving me half as many pieces on the top, and the other is saying, however, those pieces are twice as big. Okay, questions about any of that?
Nope.
Okay, now, surprise, surprise, we're going to do the same thing with our rational expressions, our polynomial fractions. Can I take this one I wrote up here and play the exact same game? Can I write it as something times something, top and bottom? I'm just going to do it for you now. Later on, we'll care that you can do this. But to keep the flow of the lecture going, then for now, I'm just going to give away the answer. So this one is x plus 3 times x plus 4 on the top. Check that that works with FOIL. x squared, 3x's and 4 more x's make 7x's, and then 3 times 4 is 12 at the end. And on the bottom, I have x plus 3 times x plus 3. Again, check with FOIL, x squared, 3x's and 3 more x's make 6x. And then, whoops, that should be a 9. My improvisational math skills have failed me. Okay, there we go. Then I can do it the same thing and say, look, there's an x plus 3 in the top and bottom. They cancel out, and I wind up with x plus 4 over x plus 3. Questions about that similar problem to what we did with the plain numbers on the other side of the screen?
No.
I'm not really asking it if you like it, because at this point it's new, but do you see how the procedure is the same as what we did on the other side?
Yeah.
Okay, now I'm gonna actually give myself more room. I think this is gonna be lots of talking. Forgot about these little white things. Let me talk about them. As an aside, when I am canceling, I can cancel things being multiplied together. Because again, I could break that apart and make a 3 over 3 is 1. That's how fraction multiplication works. But I can't cancel, wrong, when I have terms. If I have things being added in the top, I can't cancel out a 2 top and bottom there. That didn't come from a multiplication problem. So just be careful. We talked about terms before. Terms are things separated by a plus or minus. If you have terms, you don't cancel. If you have multiplication, then you can cancel. Everyone okay with that heads up?
Yeah.
Okay. This tends to not be too big an issue in Math E, but in Math C, it's a big deal. Okay. Now I'm going to get a little abstract and philosophical. So like stretch your legs, get your blood flowing. Sometimes we want to find all the factors, and sometimes we want to find prime factors. And we have two different games to do this. We've mentioned this before, but it probably disappeared from your brain mostly because we didn't really care at the time. If I want to find all the factors, then I make a horseshoe shape. We've been doing that for a while. If I want to find all the factors of 24, 1 times 24, 2 times 12, 3 times 8. Does 4 work? Sure. 4 times 6. Does 5 work? Nope. And now if there was anything bigger than 5, it would be on this right-hand side because it would need a small thing to pair up with as factors of 24. Everyone okay with that quick review? Because we've done that a bunch.
Yeah.
So on the other way, we could have the prime factors. And for the prime factors, we make a tree. So I start with 24, and there's different ways. Why is my pen acting? Different ways to start. I could do 6 times 4. I could do 2 times 12. I often get choices when making factor trees. It's polite when you're done to take all the leaves of the tree, the things at the end of the branches, and put them in order. And that way, if you're checking with someone next to you, then you don't have to mentally reorder things to see, do I get the same answer as that person? Some people like to be fancy. Okay, Pen, you really need to start working. And say, oh, 2 times 2 times 2 is 2 cubed. I don't really care how you write these. Any of that is good. Okay, so just for now, everyone okay that these are 2 different games? If I make a tree, I don't see all the factors. There's no 12 on this tree. I can miss them with the tree. When I'm finding all the factors, I don't get the same type of answer or break things down into primes. So they're 2 different arithmetic games with 2 different solutions that they're looking for. Okay, any questions or comments on that?
No.
Okay. So the trickiness then is that you have to kind of start using your judgment when you're reducing fractions about which style you like. If you wanted to say, what is 42 over let's do 150. Some people will say, I want to find all the factors in my head. 42 is like 6 times 7, and 150 is 3 times 5 times 10, and like 15 and 10 could work, or 25 and 6 could work. It looks like, yeah, this is 6 times 7, and this is 6 times 25, because 6 quarters makes $1.50. And so then I will cancel out my 6's and get 7/25. Other people will say, I like to use primes. I'm going to say 42 over 150 and break them up into primes, make trees if you need to. So this is 2 times 3 times 7. This one is 2 times 3 times 5 times 5. In both cases, I can get rid of 2's and 3's, and I wind up again with 7 over 25. So if you are fortunate, someone has explained this to you sometime in your personal math history, and you've been able to practice in both methods and figure out which type of fraction reducing you like. And you've made this intentional decision. I like turning things into primes, like on the right, or I like just thinking in my head about ways to turn things into pairs of factors. Comments on that before we go on?
No.
Okay, use your like thumbs up or type in chat or something like that. Who is the kind of person that either because you've been trained that way or you just like it better, you want to try and break things up into 2 different factors and then cancel things out and then repeat that if you need to. That's the way you reduce fractions. Okay, and who are the people that say, I like being thorough all at once. I'm going to turn things into the lists of primes and cancel out everything that could possibly be the same top and bottom.
I think I lean more towards the first option.
Yeah, I've seen a lot more people taught only the first than only the second. So if you've never tried the second one, then try it a little bit. Maybe you will like it if you've never been taught it before. Okay, one moment. I again used lots of room. Let me move these things down. Okay. When we are dealing with polynomials, then you still have both options, but it will look very different. And the way most people learn what we're doing with polynomials today, you're going to start out with this one because it is more methodical, if that makes sense. You can just keep factoring everything until you can't factor it anymore, and then you cross out whatever is the same on the top and bottom, and then you're done. This one takes a little bit more mental math skill. You have to think about it in your head. Well, yeah, 6 goes into both 42 and 150. It's not as much a routine process. So just kind of a heads up, if you are used to doing the first one, then that's probably because you're reasonably good at reducing fractions. You have that ability to stare at things and say, okay, I'll try it with 6. Or you're willing to just whittle away at it a little at a time. First, I'll divide top and bottom by 2, and then I'll divide top and bottom by 3, and I'll get there eventually. But with what we're doing, usually most people find it easiest to start with that method. Okay, let's keep going. So if I had one that had some funny denominator business, I'm not even going to care about what the numerator of this is right now. Let's just say looks terrible. Okay, can I factor x minus 2 into different things?
You could, yes, to break it down into 1/2.
I could factor something out. I could say that this is like 1/2 of 2x plus 4 or minus 4. Or I could say that it is 2 times half an x minus 1. But neither of those really gets me anywhere. That's just making it look more complicated. So one thing to realize first with my trick question is if you have something that's just a binomial, a term with x's and a term with a constant, then that counts as fully factored. I can't really make that into different parts. Whereas something like x squared minus 4, that one I can. If we want to check FOIL this, x times x is x squared. I have a minus 2x on the inside, but a positive 2x on the outside. So they've canceled out and made 0x over there. And then minus 2 times positive 2 is minus 4. So there's a difference of things here. On the top, if all I have is x's and numbers with a plus or minus in between, I can't factor that. But sometimes if I have x squareds, I can factor it. I can turn it into something with a less amount of x, only x to the first. Everyone okay with that mini lesson?
Yes.
Yeah.
So that's different. It seems strange. There's nothing like that with normal fractions. I never have to look at a number and say, is that the kind of thing that I can really do stuff with or not? There's primes that just don't factor well, but that's a different kettle of fish than the fact that you need at least a squared to get factors with polynomials. A plain x doesn't cut it. Okay, now we could finish with this. I have x minus 2 on the top and bottom. If I cancel it out, what should I leave on the top?
Can you ask that again?
Yeah, let me do a similar one. If I had 2 over 2 times 3, and I cancel out my 2's, what do I put on the numerator? What goes up in the top?
1.
1. So the same thing is going to happen. If I cancel out the x minus 2's, then you could think of it as that this was x minus 2 times 1, if that helps you. And we have a 1 over x plus 2. And that's my answer. Except it's not quite my answer. First, any questions about what I've done so far?
No.
Okay, so then I'm going to add a little bit and say with x not equal to 2, and then I can put a box around my answer if I was that kind of person. So why do I add this little disclaimer? Because I'm allowed to plug x equals 2 here. 1/4 is a great fraction. Nothing wrong with 1/4. But I'm not allowed to plug a 2 into here. Then I wind up dividing by 0. I can't have a fraction with 0 on the bottom. So when I got rid of this x minus 2 term, top and bottom, then I have something that's almost equal, but it's not quite equal, because this one I'm allowed to plug x equal 2 in, and this one I'm not. So for them to truly be equal 100% and not just almost equal, then I have to remember this disclaimer. I can't plug x equal 2 in. That won't matter for the kind of math you're doing on the GED, but if you were, especially with computer programming, having things like this happen, maybe you're finding distance over time for how fast something could go. And if you try dividing by 0, then you're going to break your computer program. Maybe it will cause a memory leak or something like that. So you would have to, in the computer program, say, yeah, I can use 1 over x plus 2, but I also have to put a note, don't let the computer plug 2 in for x. Okay, I might forget to do this because I don't actually reduce rational expressions very much in real life, so holler at me if I forget to put the disclaimers on. It is not a habit I have.
Will we need to do that for the final or the GED, I guess?
The GED is all multiple choice, so if they make you do it, then you'll be able to see it in the multiple choice answers. What the GED will do is say, here is a rational expression. what values are you not allowed to plug into the denominator? They like to ask that in that beginning no calculator thing. So you would have to look at this and say, oh, well, I can't plug in 2 or -2, because either of those would make it 0.
And what about the final?
On the final, we'll ask you that. I am guessing you would still get most of the partial credit, but yes, to get full points, you would want to put your disclaimer there. Okay, let's do a little more review of factoring and simplifying these. I'm going to just grab our textbook and let you pick one. Oops, one moment. Okay. Ooh, get rid of that. Okay. Blah, 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 blah. Here we go. Which one do you want me to do?
25.
25, okay. I'm gonna put one up on the board for you to do. But you are welcome to watch me do 25 before you start yours. I'm gonna try having you do 12. No, don't replace it. Make a new paste. Okay, there we go. So 25, how would I do that one? I look at the top and I'm trying to think, how can I factor that thing? Oops. Well, there's a 2 in all of them, and there's an M in all of them. So I can take that out first. We haven't seen a lot like that in class so far. Holler if this is too unusual and new, and I will talk about it.
It is very unusual and new to me.
Very unusual. Should I use different words and talk about things, or if you stare at it, does it make sense?
I feel like I'll be able to catch on as it's explained.
Okay, holler if that's not true. I don't want to leave anyone behind. So they're trying to trick me. They're putting this like extra factor that's common to my whole squared type polynomial. The bottom doesn't have that. There's not a number everywhere. There's not m's everywhere, right? The 6 at the end has no m's. The m at the beginning has no numbers. So there's nothing that comes out of all 3 parts that time. A lot of times there won't be this step. There's nothing top or bottom that's common to the entire top or bottom. But this case there was. So that's enough to do for one step. You shouldn't be rushed enough with the final or GED that it's a bad idea to write these step by step. Okay, in my next step, I'm going to try and factor my polynomials. I've given you lots of examples in the past week and a half about this. I'm going to use some slightly different words because both of these don't have any numbers in front of the M. So that makes these a little bit easier than most of what we've been doing. So it's going to have just a plain M to make the M squared. I also can look at the plus or minus signs. If I'm multiplying the L from FOIL, the last parts of these two, and I'm getting -6, are we going to have negatives or positives or one of each after my M's?
One of each.
One of each. And the only way this -6 can be negative is if I have a positive and a negative. So before I even think very hard, I can write M plus and M minus because there's no numbers by the M's. So the first thing is going to be a plain M squared. And the -6 tells me that it's going to be a plus and a minus. Everyone okay with that?
Yeah.
Then I want to think about the L of FOIL. Whatever these numbers are, they multiply to 6. So that could be a 1 and 6 or a 2 and 3. Those are my only options. They're going to add up to be -1 for right there. So which of these are only one apart?
Two, three.
2 and 3, right? If I have a 1 and 6, I can't get these to be only one apart to have a -1m. So I'm going to pick the 2 and 3. Which one is bigger? Should I put the 3 with the plus, or should I put the 3 with a minus if overall it's negative?
Three with the plus.
Let's see, if I do that, then when I FOIL it, I'm going to get m squared plus 3m minus 2m from the outside, and then -6. So that's going to be a positive 1 overall. But I wanted the negative m overall. So that means I have to switch these. This one is the 2, and this one is the 3. Now when I FOIL them, I will get the m squared from the first, m, and then inside is a positive 2 with m. Outside is a -3 with m. And then last is the -6. So that gives me overall the -m that I need. If I just lost you, that's okay. That was a new way to think about it, trying to sort of do more in my head. The way we talked about this last week, the slow and steady method, is to think about having a box, and we want two numbers that, like the length times width, that add up to, for ax squared plus bx plus c, they add up to b, and they multiply to get a times c. So we would have a box where we want two numbers, and with our equation over here, then the b is -1. So we want them to add up to -1. And the a times c is 1 times -6, which is -6. So the area, length times width, is -6. Then we'd make our lists again, just like we did before, 1 and 6, 2 and 3. Those are the things that satisfy the multiply to -6. one of those is going to be negative. Do I want to put, let me space this out a little bit more. 6, 3. Do I want to put the negative signs there? Could that help? Now, when I add things together, do I get -1? There, nope, that's -5. There, yes, that's -1. So there's my two numbers, adds up to -1, multiplies to -6. If that didn't work, then I could try taking my minus signs and putting them on this side to see if it added up to what I wanted. So that's how I would get the 2 and -3. Then the procedure would continue. I would take the m squared minus m minus 6 that I started with, and I would break it, the center thing, the minus m, into -3m plus 2m, because those were the numbers I got here, a 2 and a -3. And there's still the -6. Then the procedure finishes by saying, let's look at the first two. They always have an m in common. Let's look at the other two. In this case, they have a 2 in common. And lo and behold, the second thing always matches, which means these two I can pull together to make the first binomial. Does that look more reassuring for people who were with me the last week and a half?
Yeah, a little bit.
Yeah, a little bit.
Okay, so depending on how much homework you have done, then when you're looking at the things we're doing today, you might always want to do them this way, because this way always works. It just takes a lot of writing. Once you get more kind of brain practice, I'm starting to one wheel, and it took me about 20 miles before I would not just like randomly fall off and felt safe to go on the side of the street. So, I don't know, once you get used to it a little, then you can do the kind of thinking I'm narrating here too. Okay, let me do another example of the narrating style. So we need plain m's. We can't get m squared if there was like 2's and 3's and stuff there. With a +6, am I going to have 2 minuses, 2 pluses, or one of each? They're going to be the same, right? It has to be 2 positives multiplying to make a positive or 2 negatives. So whatever they are, they're the same. Then I look at my middle term, what I was just calling b a moment ago. That one's negative. So they're going to both wind up negative. This one tells me the same. And this one says, not only are they the same, they're negative. And now I just need two things that multiply to 6 and combine to 5. So that's a 2 and a 3. Okay, now I will do my canceling. And I wind up with 2m times m plus 2. All of that over m minus 2 with m not 3. And that last step should make more sense than the rest of it, because that was the same as what you do with fractions. I see the same thing on the top and bottom and cancel it out. That looks like something that's not just a parenthesis. Okay. Questions on that problem? We move so you can see the whole thing. The good news is you picked a hard one. This is as hard as they get. Why was this as hard as they get? First of all, because it has oh, wait a minute, I have a highlighter. It has the annoying extra step of there was some 2m everywhere. Next, it has the normal amount of hard work of this is two different problems from last week stuck together. I have to factor both of those, not just one thing, right? Either one by itself was a homework problem last week. And then lastly, well, canceling really isn't any work, but remembering to put that disclaimer to get my last little bits of partial credit and full points, and that I have to do.
So, does every time that you have to do some kind of canceling, do you always have to put that disclaimer up, or does that just happen to be the problem we're on?
The only time you wouldn't is if the thing that you canceled was already in the denominator. So if it was, oh, what do we just go off to the side. Let's say your fraction after you reduce it is x minus 3, x plus 5 over x minus 3, x minus 3. So now when I cancel the x minus 3's here, I don't have to write the disclaimer because what I have left over already tells me I can't plug 3 in. Does that make sense?
Kind of. I think I just have to get used to doing the disclaimer in general.
Yeah. That's a good question, though. Early on in the term, we talked about how if you're not used to dealing with equations, they're kind of weird. Let me go back to the very beginning of things. If I write a normal number, you can tell me lots of things about that. You know, it's not very much if I'm wondering how many M&Ms to eat. It's a huge amount if I'm wondering how many grams of medicine are in a prescription bottle. It's positive, it's prime, you know, things like that. Whereas if I give you even a very simple formula, I can't tell you those things. Right? If I plug if x equals 4, then this becomes 1. If x equals 0, this becomes -3. If x equals 3.5, this becomes 0.5. So is this thing positive or negative? Is it a whole number? Is it a fraction? Those questions don't make sense anymore. It depends on what you plug in. So it's a mental shift when you see formulas to think, what happens when I plug in different things. You know, what breaks it, like dividing by 0? Or when does it switch from positive to negative? If I cared about that, I don't want the airplane to go underground, like in the beginning of Die Hard. Or is that the second one, Die Hard 2? Anyway. Yeah, functions can be weird. Okay, moving on. Your turn. I'll be your scribe. Tell me what to write. Let me make it bigger.
Would it be 11 apprentices A plus 33?
Just A plus 3. 3 times
Oh,
11 is 33.
oh, right.
So that's great.
Wait,
What
why is it
about,
just three? Why is it just three?
because when I distribute, I get 11A and I get 33.
Okay.
So that builds what I have over there.
So would that make the bottom 6 apprentices A plus 3?
Yep,
Because 6 times 3 is 18.
correct. Okay, you're almost done.
That's about as much as I've got at the moment.
Okay, tag team, who's going next? Pick someone, Anthony.
I don't want to call people out.
You know, I'll pull people out. Brenda, you've been
Um,
quiet. What should we do next?
I'm sorry, I'm putting my kid to bed. Give me 1 second.
Okay, Vincent, can you say something? I'm just going down. I'm not being picky on people. I'm just going from left to right on my screen.
Oh, you're good. I'm assuming multiply each, so like 11 by A and 3.
That would bring me in this direction. I want to make things
Oh, you want to
simple.
go back? Okay.
Rebuild what I did. Remember, our theme for the day is canceling.
Right. Cancel
oh,
3 plus 3.
Can I cancel A part 3?
Yeah, there we go. So I wind up with 11/6. And also we can't plug A into, we can't plug -3 in for A, which looks really weird because there's no A's anymore. Okay, great. Ta-da, you did it. Okay, there's a few more things that are sort of special cases I want to point out. If I have a fraction that's something over the negative of itself, what does that simplify into?
doesn't that just cancel out? No. 1.
-1.
This becomes a -1 times 3. And then when I cancel the 3's, I get 1 over -1. And that's a -1. Whoops, leave room for my negative sign. If you have something over its negative, then that's -1. It's the same even if the top one is what's negative. Doesn't matter whether the top or the bottom is negative. Many students memorize a rule that I can just take the minus sign and move it to the front. And then I have 5/5, which is 1. Or I take the minus sign and move it to the front. And then I have 3/3, which is 1.
With the exception that you put the negative sign back in front of it, right?
What if I can make it a whole number, then I might as well do that. That's part of the requirement to fully reduce.
Right. So so what I'm saying is like if you have a negative sign and it's 5/5, you go, oh well 5/5 is 1. But once you put that negative sign back in front of it,
Yeah, I see what you're
so it
saying.
would
Yes,
be
-1.
yeah.
Yeah. So why is that true? Do you need me to explain why that works?
Sure.
So if I have say like a deck of cards. Okay, so I have 6 cards in my hand. And I have 3 friends. There's 2 ways, to think about division. The way most people are taught is that I'm dealing out cards. So if I want to do 6 divided by 3, then I take my pile of 6 cards and I say, you get one, you get one, you get one, you get one. Everyone gets dealt out cards. And then we know 6 divided by 3 equals 2. Where is the 2 in my answer?
You'd have to be one of the people playing cards.
Yeah, the 2 is how many cards each person gets. Everyone okay with that? Does that make sense as how division works? That doesn't help us with other kinds of problems, though. And I'm not sure why elementary school teachers don't teach you better things. If I have a similar problem of what is 6 divided by 0, I'm not sure how to do that. I mean, even if I got rid of all of my friends, I'm still not sure how to deal out cards to 0 people. And similarly, if I had 6 divided by 1/2, even if I like took my samurai sword and sliced my friend in half, I'm still not sure how to deal out half a pile. I'm just dealing out maybe 1 pile to what's left of a friend. So dealing out cards is limited as far as how it helps us think about things. So another way to think about division is making piles of a fixed size. I'm going to ignore all my friends. Let's go back to 6 divided by 3 equals 2. I have 6 things. I'm going to make piles of size 3. 1, 2, 3. There's 1 pile. 1, 2, 3. There's another pile. Now where is the 2?
Two piles.
2 piles. How many piles I make before the end? So now you can sort of see why 6 divided by 0 is something that behaves like infinity. If I had all of these in my hand, then I could make as many piles of 0 as I want. I'm never going to run out making piles of 0. And if I wanted to do 6 divided by 1/2, well, I could take my 6 things, and this is much more dramatic if I'm actually having pieces of paper in front of me. Imagine that I am now ripping my piece of paper in half. Okay, so there's 1 thing, 2, 3, 4, 5. So now I have 6 things. Let's make piles of 1/2. Ready? So 1 pile of 1/2, 2 piles of 1/2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 divided by 1/2 is 12. And I didn't need to do anything bizarre to get that answer. I just ripped things in half. If you kind of meditate on that, you can see why it's true that you divide fractions by flipping and multiplying. This 2 comes up to the top to make 6 times 2. It's because the more pieces we rip our holes into, the more piles we make of tiny pieces. Okay, we've gotten very philosophical, but now I can finally answer your question. If I say 6 divided by -6, whoops, divided by -6, if I'm dealing out cards, it again doesn't help me. How do I deal out cards to negative friends? Or how do I deal out negative cards to friends? The second one I can kind of do. If I had a debt of $6, I could give my 6 friends each a debt of $1 and see that the answer is -1. But you could also say I have 6 cards in my hand. How many piles of -6 can I make? How many like -6s can I get out of 6? Well, a -1 copy. To me, that makes some sense. Okay, that was a lot of philosophy of division. Sorry if that was not what you wanted. It is past 7. Should we take a break?
Yeah, actually, that's okay.
Okay, when we get back, we're going to use the same top and bottom negative thing to look at a tricky case when simplifying. So I'll see everyone in 5 minutes. I'll pause the recording. Stretch your legs. Okay, with the polynomials, this top and bottom are negatives of each other can look a little different. So up here, I have x minus 3 over negative of that. If I distribute the negative sign to the x and then the -3, what winds up happening is the x becomes negative and the 3 becomes positive. And then I can rewrite the bottom as 3 minus x, just by putting the 3 in front and the minus x in back. So this interesting thing happens. If you have a x minus number kind of binomial, 2-part polynomial, and you negate it, then they switch places. X minus 3 changes to 3 minus x. So that's a special case to keep an eye out for because it doesn't do that with normal numbers, right? 5 over -5, it's not like you get the mirror image of 5 or something strange like that. On the other hand, if you don't catch it in time, it'll just work out as usual with the normal process. So if you don't notice a shortcut, that's okay. So for factoring, we then have two kinds of problems. We have ones that work like normal fractions. Oh, it's the same thing, top and bottom, but there's a -1 on either the top or the bottom. So that becomes -1. Oh, my timer was happy. Experimental timer, go away. Okay. Or as a very different kind of problem, we could have a polynomial where x squared minus 25 becomes x plus 5, x minus 5. Can I make that happen on the top? Sure, the top is a negative of x minus 5, because a negative flips the order of the two things that are being subtracted. Then I have my x minus 5s to cancel, and I get -1 over x plus 5. With x not equal to 5. This one I should have also put with x not equal to -7. So things to pay attention to. Okay, questions on any of what we've done so far tonight?
Do we have time to do one more of those?
I'm actually going to make it worse than that. We have lots of time. What we've done so far, as I mentioned, is slightly intense compared to last week, because last week you would have been happy just being asked to factor one of those, and now every problem has two of them. But we're going to do something even more than that. Instead of just looking at fractions one at a time, let's do some arithmetic with fractions. And this will seem imposing because fraction arithmetic often sort of is post-traumatic algebra syndrome for people sometimes, but you know how to do fractions. So this will only be long. We might have to factor two fractions, each of which has a polynomial top and bottom. So we actually have to factor 4 times in one problem. But it's just long. It's not actually any worse. You just have to be slow and careful. So let's start with multiplying, because multiplying is easiest. We're putting things together. There's a whole lot of nice stuff here with practice problems to look at in the book. Let's do 9. But I'm skipping over all of the chapter because you do know how to multiply fractions. So the only thing that's new is that we're making you do a bunch of other math problems in the middle of it. Okay, I have a squared plus 5a. Well, there's an a in both of those. Seven a, I can't do anything with that. 4a squared, okay, great, no problem there. A squared plus 4a, okay, a plus 4. Now, what can I cancel top and bottom?
Well, it kind of looks like nothing, but I guess there's the A.
There is the a, like this a and that a will cancel. And over here with the a squareds, I can cancel this a with one of the two, because that's a times a. So what do I wind up with? Now, this is something that you will want to ask me about, but it actually doesn't matter. How do I write my answer? Do I keep it all as factors? Or do I combine these and make it 4a squared plus 20a over 7a plus 28? And the answer is either one works, because I'm not sure what your real life situation is. I don't know if you are about to do more fraction math, in which case keeping it factored would be handy, because you're probably going to have to factor it before you do any more fraction math. Or if you're just trying to like report something that looks nice, and some people might like that better. But on the GED, you would be able to look at the multiple choice and pick one of them. And on our final, you could write it either way. I don't care if you smash things together at the end or if you leave them as factors. Questions about that problem? Oops.
So that's the answer. It doesn't
That's the
go any
answer.
further than that.
Yeah. There's a lot of stuff that didn't cancel, and that's okay, right? Just like when you multiply fractions, you don't expect it to always cancel down to 1/2 and reduce that much. Some fractions are just bigger, and that's okay. Okay, let's do a division one. How about 19? Oh, no. Okay. So again, I'm going to factor these. We have 4 different factoring problems, heck, right? 1, 2, 3, 4 things here that need factoring. So I'll do it for you, because the point of tonight isn't how to factor. That was the last few lessons. But these take a while. That's okay. When I didn't do quite as many example problems of some of this stuff earlier, it's because, yeah, when you do catch up on homework from last week and do this week's homework, you're going to get more than enough practice with this annoying stuff. So. Okay, top of the first fraction, there's a y squared with both, and a plain y and a -5. And then there's a y squared everywhere here. That's nice. And I get y squareds plus 3y plus 2. Everyone with me just for this fraction? That's all I've done so far.
Yep.
Kind of.
Okay, now I'm going to say we're dividing that by nothing in common everywhere up top. That's just well, the 6 says they're the same because it's a positive 6. The minuses, they're both going to be negative, so it's going to be y minus something, y minus something. And multiply to 6, add up to 5, that's 2 and 3. Down below, -3, they're going to be different signs. So we're going to get a y plus and a y minus. And they're going to multiply to 3, so it has to be 3 and 1. The bigger one should be negative to make a -2. So that's the 3 and that's the 1. Everyone okay with my first step of just factoring a little?
Yes.
Yep.
Now, on my first fraction, I didn't fully factor that. I'm going to make some careless mistakes if I try and do too much in one go. So I have a y and a y. It's all positive, and there's a 2 and a 1. It doesn't matter where I put it. For my other fraction, I did finish factoring it, but I'm dividing fractions, so I need to flip. And then if I multiply fractions, all that's really doing is like saying they're the same thing over one big fraction bar, right? It's all just multiplying. So I can think about what reduces. Okay, now it's like, where is Waldo? So we're done with arithmetic, we're on to eyesight testing. What things cancel?
The y squared.
Boom, okay, there we go.
Y -3.
Yep, y minus 3. One more.
Oh, the y plus 1.
Yeah. This is very similar to if I had like 9 times 5 times, well, 1's not going to work. I'll just say 7 times 3. And let's put that more in the middle. And this is 9 times 2 times 7. And -2 times 3. So kind of the shape of these two problems is the same. They're very different problems, but in both of them, I'm saying I have fractions. I've factored the numerators and denominators. When I multiply fractions, that's just basically saying smush them together and make one big top and bottom multiplied together, right? Multiply the tops, multiply the bottoms. That's how we multiply fractions. And then what did I cancel? There's this thing in the front that's like a square. There's these things that were with the ones. There's these 3-ish things, right? So the shape is the same as what you're familiar with, even if it looks much different with polynomials. Okay, finish up. We're not done. So what did we have on top? All that was left was a y minus 5. And on the bottom, we had a y plus 2, y minus 2. And if you like smashing things together, multiplying makes you happy, you could certainly write this as y minus 5 over y squared minus 4.
Oh.
But all you really need to be able to do is recognize in a multiple choice answer set this one, if that's what you got.
So if you were doing an assignment or the final or anything, if you wrote the negative y negative 5 over the y plus 2, and yeah, that one, would that still count as correct?
Yep, that's correct. That's full credit. There's nothing wrong there. Just like if you were doing fraction math, would you write an answer as 1.5 or 1.5? They're the same. If you're doing computer programming, you probably want 1.5. If you're doing baking, you probably write at 1.5. So kind of your context tells you what's the traditional, what's the useful way to write it that your audience would want. But these are just problems floating in the void. I have no idea what's going on here in real life. That's why we did last class a bunch of things with drones flying and populations changing and retiring and probability and trying to make some real life sense of these. But we're not realistic today. We are just having numbers floating on paper for no apparent reason. I want to do an addition or subtraction one. So that means that these uniform motion problems, we will save them until Tuesday. If we go into Moodle and look at your homework, then uniform motion you won't be able to do till Tuesday unless you learn it on your own. So try homework this weekend of these 3, but don't worry about the 4th one.
So how many weeks do we technically have left of class?
The class time itself goes for 10 weeks. So we are finishing week 7. So we have week 8, 9, and 10 together. The last week, finals week, then we'll do a final. And if you want to come in and do the final in the classroom, you certainly can. The people who have been in the room a lot this term, it's sometimes just kind of you're in your groove better if you're taking the test the same place that you sat and saw everything on the board and so on. If you want just to have the final sent to you and you do it at home, that works too. I don't think I'm required to proctor them, although if I'm wrong, I will let you know. Since the class isn't graded, then I think the 2-hour time limit is mostly an honor system thing, unless you had an employer that was saying, I want to really know that this person passed, and then you should do it in person. Or I would email it to you and check back in 2 hours, not just have it sit in your inbox. So anyway, and then the other thing we do in week 10 is after you do your final, then we meet together and do a kind of get a sense of what you know and don't know. Because there will be a lot of silly mistakes on the test. There's just so many things you do that after 2 hours, your brain starts getting tired and you make silly mistakes. So what I will do is, you've seen how I can grab things from the screen and put them on the whiteboard. I'm going to make a whiteboard with all of your silly mistakes from all of you, or at least a bunch of silly mistakes from all of you. And then we'll get together after the final, later in the second half of finals week, and usually one-on-one, but some people have buddies and like to meet together in Zoom or in person, and that works too. And we'll talk about this whiteboard of silly mistakes. And that does several good things. First, any silly mistakes that were yours, you can show me that you can fix them. It's not like, after 10 weeks of work, Dusty made silly mistakes, the end. Right? That doesn't feel good. So you get to show that, yes, you really know that. Of course, it's just that tests don't always show us what we know. And also you get to feel like you're kind of the teacher and grading everyone else. You won't know whose problems I'm copying for the ones that weren't yours, but you can say, oh, look, somebody forgot to do this negative when distributing, and I know how to do that, and so on. So it kind of feels good for that reason too, of, oh, I could grade this kind of homework, I could be the teacher. So that's what week 11, finals week, is like. Once we get closer to that, I'll make appointments, because not everyone is going to want to try and do their meet together to talk about the whiteboard of silly mistakes on Thursday between 6 and 8. So we'll schedule different times to get together. And for most people, it takes somewhere between 30 and 50 minutes based on how into it you get of correcting everyone's silly mistakes. Sound good?
Yep.
Okay, real quick, can I add fractions before we're out of time? I will have to do a pretty easy one. Should I go ahead and do unlike denominators? We all know that fractions are trickier if the denominators don't start out matching.
Sure.
Sure, okay, 28. That looks both slightly complicated and fast. Honor our time, as well as show you what you need to see. Okay, I have two fractions. I want to add them up. I don't know where they came from. I don't know why I want to add them up, but okay, let's go. 5 over a, that looks nice. And 20 over, that looks like something I can factor. What do I do with a squared minus 4a?
A parentheses a -4.
Yep. Everyone happy with a little bit of factoring?
Yeah.
So this is very equivalent to if I have like 5/7 over plus 20 over 7 times something else. How would I get common denominators in my green problem? I want to multiply this one by the same thing, top and bottom. What should I pick?
I was just gonna say that. That's funny.
Multiply by the same a fraction, teacher. A and a minus 4.
You're up here. You're jumping ahead. What do I need to multiply this 7 by to make it match 7 times 13? Don't think too hard about this.
There's 7.
I don't want 7 times 7. That's not the same.
13.
13. It has the 7
yeah.
already. Right. So I don't have to know what 7 times 13 is. I just know that whatever that is, now they match because they're both 7 times 13. So we're going to do the same thing. I have the a already. So I'm going to multiply the top and bottom of this by a minus 4.
Yeah, that's
Because
what
now they match. The bottoms match. So it's nothing new. It's the same fraction stuff you already know. It just looks really different. Okay, so what do we have now? we have 5 times
A
a minus 4 plus 20 over a times a minus 4. Because that's how we add fractions. The denominators stay the same and the top adds, right? So these parts I can combine. So I should. I have 5a minus 20 plus 20 over a times a minus 4. Everyone with me so far?
Yep.
The minus 20 plus 20, well, that's going to go away. So I have 5a over a times a minus 4. Am I done?
not yes.
No.
Can cancel A.
Cancel a, okay. Oops, I'm not quite done. Because I also have to say
A disclaimer.
with a equals 0, because I got rid of a thing on the bottom. Okay, I'm expecting this will be one of the more viewed class videos. There's a lot of this that you just sort of have to, listen to Pink Floyd and watch it happen kind of meditatively, and then you'll say, oh yeah, that really is the same as adding fractions. All I would have to do is say 5 times 13 is what, 50, 65, plus 20 over my 7 times 13. I don't even care what 7 times 13 is now. So that becomes 85. Okay, now I should figure this out. So 70, 21, 91. Any common factors? No, I'll put a box around it. And so you know how to add fractions. It's just a little different. It looks different. Things like how you reduce are different. Putting the absurd disclaimer at the end looks different, right? But the general process is still the same. So you can do this, it just will take some practice. And I wish that math was like the Matrix movie and I could just, plug a tube and the back of Kayla's back and ta-da, she knows rational expressions and can do them like an experienced martial artist. But no, you have to
That
do
would
homework.
download
It's
so
the
much.
only way to get fast at it. Okay, I'm gonna stop the recording.